Alright, we're on to the final category, and this is how to solve rational equations. So let's get right to it. Alright, so whenever we're ever solving rational functions, especially when it looks like this, we want to make sure the denominators are all common, they have the same common denominator. So here, what can we see? I mean, first of all, I can see there's an x squared minus 25. So x squared minus 25 is just x plus 5, x minus 5. So now we can just rewrite this whole equation as like
3 over x plus 5 minus 3 over x minus 5 equals x minus 25 over x plus 5 times x minus 5.
And now from here, now look. Well, there's an x plus 5 here, and there's an x minus 5 here. And this has both. So basically what we have to do when we think about it, we could just multiply an x times x plus 5 here and an x minus 5 here. And then we would get this, because this is our least common denominator. So what we could do here is we could just multiply it by x minus 5. And then, of course, make sure that the top is x minus 5, so it just stays as 1, because this is basically just 1. If anything over anything is always going to equal 1 itself. And yeah, so then after you multiply like that, then you get the same denominator as this, while maintaining math standards of just, because you're just multiplying 1, basically. You're just simplifying. So same thing here. I mean, x minus 5. Well, there's an x minus 5 here, but then there's an x plus 5 that we don't have. So over here, we could just multiply by x plus 5. And of course, we have to multiply the numerator by x plus 5 so that we can keep it as 1. X plus 5 is just 1. Same thing here, is just 1. So now, what we do, we have this common denominator of x plus 5 times x minus 5. So now, everything can be put, so look. Now we have here, since this is just going to be, all of these, the denominator is just x plus 5, x minus 5. So now we just multiply the top by whatever we multiplied it by. So here, 3 times x minus 5. So look, 3 times x minus 5. Let's keep it under this for now. Minus 3 times x plus 5. Equals x minus 25 over x minus 5, x plus 5. So you see, now they all have the same denominators. So now what we can do with the same denominator, basically just take away the denominators now. Just forget it. I mean, that's because since they're all the same denominators, now all we need is the top bit. So now, instead of having the x minus 5, x plus 5, they all have the common denominators, right? So don't worry about that. Just take the denominators out of the question. You see the 3x minus 5, and then you take the minus 3 times x plus 5 equals x minus 25. And that's our new equation. A lot easier, right? It's because since we got the common denominators by factoring x squared minus 25, and then multiplying each of these by this side by essentially 1, but of course they were by the factors to make all of them match the common denominator of x plus 5, x minus 5. And now that they're all the same common denominator, now we have an equation without any sort of dividing or anything. So now let's simplify. 3 times x minus 5, 3x minus 15. Oh, negative 3x. So remember, we have to distribute the whole negative. So it's now negative 3x minus 15. And that's equal to x minus 25. So now from here, it's just simple algebra. Now we have 3x, negative 3x. You see that? Those two cancel out. Negative 15, negative 15. Those just add up to negative 30 equals x minus 25. From here, you can just add 25 to both sides. And then here you get -5 equals x, or x equals -5. And boom, that's how you solve a rational equation like this. Of course, the next example will be a bit different, but basically what we did is we looked at the denominators, we made them common by multiplying them by some factors over themselves, so that's still 1. Like in this case, it was x plus 5, x minus 5. That was our least common denominator because x plus 5, x minus 5, these had each of them, but they didn't have the other one. Like this one doesn't have x plus 5, but it has x minus 5. And this one has x plus 5, but it doesn't have x minus 5. So what we did here, we just multiplied them by whatever they needed. And then, of course, we multiplied the numerators to keep it 1, so that we weren't actually changing the equation anyway. And here, x plus 5 over x plus 5, both in the numerator and denominator. And then we got our common denominators, and we got our top terms. And now that they all have the same denominators, you can just get rid of that. And then now it's just a simple equation of the numerators, where you got 3x minus 5, 3x minus 15, minus 3x minus 15, and then equals x minus 25. That just stays the same. This equals -5. Last step, though, you have to plug it in to make sure that it's not an extraneous solution. An extraneous solution just basically means like you solve it and you get x equals -5, but actually when you plug it in, it doesn't work. So let's see, -5. Oh, you can see clearly, I mean, x plus 5, if you plug in -5, you get 0, and 3 divided by 0 is undefined. So, like, first of all, that's a big flag. You can't, in an equation, if one part is undefined, the whole thing is undefined. So, it can't be a solution. X equals -5, which is the only one we found. So, no. Also, if you plug -5 into here, I mean, x squared, -5 times -5 is 25. 25 minus 25 is 0. And then you get x minus 25. Okay, -5 minus 25, -30. It's -30 over 0. Like, come on now. That's 2 parts of the whole equation on both sides are undefined. So, it's not even that it's 0. It's undefined. So, therefore, x minus equals -5. We may have found that, but actually, there are no real solutions, because x minus 5 is an extraneous solution. Always make sure in every problem, you may find the common denominator, you might multiply everything by the common denominator, and you might simplify, and then you might get it, but you always have to check and make sure that it isn't an extraneous solution, because these can be tricky ones. You may jump to conclusions like, oh, I found the answer, let's go. But actually, there's no solution, because when you plug it in, you get a bunch of undefineds everywhere. And how can that equal an undefined number? So yeah, let's go into another problem. All right, so here is our second problem. And now, first of all, solving a rational equation. This might be a bit different, but all of the same principles still apply. What's the common denominator? We must look at that first. And now we look at the denominators, 2x plus 1, 2x plus 1, x plus 5, x plus 5. We got only those 2 terms. So now our common denominator can just be the multiplication of those 2, x plus 5, times 2x plus 1, right? If we have all of those denominators the same, that's our common denominator, since they multiply to each other. So now what we can do is multiply this whole side by that, and make sure that both multiply the common denominator on both the numerator and denominator, so that it stays as 1. So over here, the x plus 5, 2x plus 1, x plus 5, 2x plus 1. And this is that because it still is 1, because they're all both divided by itself, so it's just 1. So now, let's multiply them by the numerator and denominator. And yeah, let me show you. Let me just put a line here and show you. 4 times x plus 5, x minus 2x plus 1 over x plus 5. Remember, this is just multiple. And then my camera cut out, but this is basically after you multiply that, the common denominators, by the whole thing. You get all of this, 7x. You get the gist. X plus 5, 2x plus 1. You're multiplying that by all of these, 4, 7, 5, 2, because they're by the tops. And then after you multiply all of those out, and then you can see, oh, now you can cancel these out. Nice, right? 2x plus 1 and x plus 5. And now with that, you can simplify even more. Now, 4 times 2x plus 1, see? 7 times x plus 5 over, now it's just one denominator, 5 times x plus 5 times plus 2x plus 1. And now that we got this, of course we can simplify even more. The 4 times 2x, 8x plus 4. And now we can get them into like terms. Plus 7x plus 35. You see? That's the whole top part. And then the bottom part, 5x plus 15 plus 4x plus 2, which is the bottom part. Now from here, just combine the like terms and get 15x plus 39 over 9x plus 17. And don't remember this whole thing, now I can add it back in because now I'm done with this whole left side. And now look, we went from this huge number just by multiplying it by essentially 1. And now we got this nice fraction. And then this is equal to 5. So now, from here, now basically 5 is basically 5 over 1. Now we can just cross multiply. Alright, let me bring that up here then. So now if we cross multiply, that's 5 times 9x plus 17. And then that's equal to 15x plus 39 times 1, which is just 15x times 39. Simplify this out. You have 45x plus 17 times 5. 17 times 5. Okay, I do not know that. 85 equals 15x plus 39. Now we just subtract 15x, subtract 15x, subtract 85, subtract 85, and then you get 30x equals 39 minus 85. Let me just write that a bit better. Which you get, and then you just divide 30 by each of them. And then you get x equals negative 46 over 30, which can be simplified to, since they can both be divisible by 2, of course. And then this goes to negative 23, and then this goes to 15. It goes negative 23, 15. And that's our answer, boys. We went all around. And basically, 4 things you need to know to solving a rational equation. 1, find the common denominator. 2, multiply everything by the common denominator like we did here, the numerator and denominator. Just make sure that it's both over each other so that it's 1 and it doesn't change any of the the fundamentals of the problem. And then 3, simplify everything. And then 4, check for extraneous solutions, which I would do now. This is a huge number, so I'm not going to ask you. But when you plug this in, it is an extraneous solution. But the point of this video is just, this problem is made up from my numbers, but No wonder it's extraneous, but yeah, you solve rational equations.